Okay, can everyone see my slides?
Yep.
All good?
Looks good.
Okay, so welcome to the session on community preparations for early science with Rubin. Bob and I will be your hosts for today. For those of you who don't know me, I'm Leanne Guy. I'm the construction projects data management scientist, and I'm the interim AD for the system performance department in operations. I'll let Bob introduce himself.
Hi, everybody. I'm Bob Blum, the acting director for
Okay, Bob. Oh, no, what's happened?
here today.
Okay. Okay, so I'll let Bob start us off with some friendly reminders.
Sure. So I know some of you are thinking you've seen this a lot, but we're going to keep giving it to you until we all behave in the right way consistently going forward. So these are important messages. We signed up for the code of conduct, and we're going to hold ourselves and you to it. You know that we adhere to high principles of how we treat each other and work together as we do these meetings and interact generally. So we are very appreciative of your support in that. And of course, any discriminatory behavior will not be tolerated. And if you witness anything, please do contact someone through the Code of Conduct resource page. Next slide, please. So we are being recorded. If you don't want to be recorded, shut off your video and audio. Otherwise, we'll all behave well, and we'll be proud of what we see on the recording tomorrow. That's when we will post the recording from this session. So do use Slack, give thumbs up to questions, and we'll try and get the most popular, interesting questions answered in real time, and we'll continue to answer questions as we go forward after the session. And please show your appreciation for the questions and the things that you hear today. We said we would take comments on Zoom as well, but let's try and stick to Slack. That way they're easily recorded. And we have Chuck Claver monitoring Slack for us. So one thing, Leanne, we didn't discuss was how often we're going to pause for questions. Do you want to go through a few slides first and then pause? I'll let you decide.
Leanne said that she was having an issue with her audio and that she might have to disconnect and reconnect.
Okay, so I apologize. I've got a problem with my sound and I have to drop off. I can't hear anyone. So I'm going to ask Bob to share the slides and keep going. I have to drop out of Zoom and reconnect. I have no idea what's happened.
Do that just fine.
Do you all see the slides now?
Yep.
Yes.
Okay, so let me keep going. So I'll just cover for Leanne until she gets back on.
Thanks, Bob. And I can hear you. I don't know.
It's all yours. Go for it.
Thank you. Okay, so just a few notes on the session format and logistics today. As you just mentioned, we're your chairs. We have a Slack channel following the same format in the Rubin 2020 PCW Slack, day 3, slot 3A early science. Chuck Claver will be monitoring for questions. Please keep the discussion topics, the chat and questions asked within this Slack channel. We will not be monitoring the Zoom chat for questions. When you ask a question, Chuck will queue up the questions and he may ask you to unmute so you can ask your question during question and answer time. Please also feel free to use the Zoom raise hand. We will monitor the raise hands on Zoom if people want to ask questions, but not the chat. We have a Google Doc for live minutes. Keith Bechtel is our nominal scribe. Thank you, Keith. This link, however, is a link that is accessible to anyone. If you would like to add some notes during the session, or there's something that you'd particularly like us to remember or follow up on, feel free to go into this document and add your comments. Bob? Okay, so just a quick note on the session goals for today. This parallel session is meant as a starting point for discussion as the project enters into planning and preparations for early science. We want to work with the community as we prepare for the early science program. We will start by explaining exactly what we mean by early science, and then we will present the current status, the plans, and the various paths that there are to success with early science. And then I think we really want to listen to you, the community's input, and to understand how to work with the community on planning for successful early science.
So this is one of those deals where you probably, everyone has a different opinion of what early science is, but when they see it, they know what it is, even if they can't describe it crisply. Certainly what we think of as a good working definition is anything that happens before data release 1. You will all remember that, data release 1 happens after a year's worth of relentless survey data taking, or 6 months, and then it takes 6 months to process. And strictly speaking, we weren't even going to have alert generation until we had data release 1 in the can, so alerts wouldn't, really be coming until year 2. So we're talking about all the things that we could do before that happens. And it's also true that there's been a lot of expectations built up over the years because of the sense of what we would have coming out of science verification and commissioning. And you know that in recent times, some of that has been compressed. So we want to be more precise now, we want to be more clear, and we want to have multiple options and ways of thinking about what we could do depending on where we end up right before operations starts, because we still know exactly what that'll look like given everything that's happening. And we also have informal guidance from NSF, and I think quite properly so, that they want to ensure that things happen soon after we start taking. It's been a long road for everyone to get to even to this point, and by the time we're taking data, we want to make sure that people are doing science as soon as possible. That's your reward for sticking with us all this time. So the next 2 slides come from Chuck Klaver and Keith Bechtold, and they specifically talk about things that we might do in commissioning and science verification, which is important because depending on how this goes, that could produce things that we end up putting out to the community for doing science. And then we're going to also talk a little bit later on what we can do in the first year, depending on how we enter into full operations to provide opportunities for early science. So think of those two different aspects, things that might come out of commissioning and could continue into like the processing of in the first year of operations, and things we might do in the first year of operations depending on the status of the system as it comes out of commissioning. In any case, the current plan that Chuck and his team have developed is down to 8 months of on-sky commissioning. So that's 3 months of dedicated work with ComCam and 3 months of dedicated work with the main LSST cam, Rubin's LSST cam. And then 2 months worth of science validation or verification surveys, where the goal would be certainly toward the end of this whole period, those would look a lot like what we're doing in real operations and real data taking, but not necessarily exactly the same. So those are the opportunities of data, science-like data that could come out in, or should come out, and I think certainly will come out in commissioning and science verification. And this slide just shows a little bit more detail on how those items might look in the current planning. So, a wide field type survey, full depth survey, those kind of things. So these are going to definitely present, if at some level, opportunities to do science early on. And so that's what the commissioning team is going to do. They're concentrating on getting the system working, and to the extent they can, producing some science-ready data that we could then present to the community. That would come through the operations team and through the early operations or pre-operations activities, where we would take the things that come out of commissioning and make them available to the community. The commissioning team itself will have some interaction with subsets of experts and other people in the community helping with commissioning. That's a commissioning activity. we're talking about making generally available opportunities for the science, the data rights community to work with early data. And the primary way that we envision doing that is through so-called data previews, which would be like data releases, but you could imagine the quality, the extent, what we produce and what we make available will grow steadily over time as we go through the commissioning, science verification, and first months of early operations. So we will be aggregating data that comes from ComCam as appropriate and available, and data that comes from LSSTCam as appropriate and available in those stages, and putting it together in a data preview. Now, data previews will be used to train the operations team as much as to train the community and provide science opportunities. So these are activities that are very important to essentially everybody in the Rubin sphere, so that we're all ready to operate and do science in year one. So we're actually collaborating early on with the DESK collaboration and their simulated data set to provide a data preview based on that. And we hope that comes out in FY21. That's what our current plans are all driving for. And then data preview 1, as currently envisioned, would be concentrating on the things that come out of ComCam that can be usefully shared with the community. And data preview 2 would be the things coming out of the science verification and validation surveys. So that's kind of a baseline plan. We're in the middle of the COVID pandemic. We haven't restarted construction yet. We don't know exactly what a rebaseline program will look like for the construction project and exactly when we'll start up operations. So there's a lot of uncertainty. One can easily imagine there'll be a lot of pressure to finish the project safely and get into what we call operations. So the exact nature of what will happen in commissioning and the exact nature of what the system looks like in early operations is not yet known. So what we're going to do as an operations team is make several different plans that we could deploy or implement depending on what happens 3 years from now and where we're actually at. So one option, of course, is everything goes just like I was just describing. We have plenty of time to do the commissioning, the science verification. We end up great and we're off and running. One of the things that Leanne will discuss in a bit is this idea of generating templates as we go along, which was not part of the original plan, but is now being factored in. I'll let her describe that. We could have hugely successful commissioning and science verification and huge amounts of templates generated already through that process. And that would make early science almost automatic as we start executing the survey normally in year one. It could be that we get there and the system is ready, it's verified, it's validated, the construction project is finished, but we haven't had the chance to do everything we wanted to do to be operationally ready, in the sense of knowing exactly what all the processes were on Sky and things. And that you might envision that would require us to do some more work in the first months of operation to take care of. So there's possibilities here that we won't know of until we get closer to that period, and we'll plan for all of them, and we'll implement the best plan at that time. So what might that look like if we had to do some extra work in the first part of regular survey operations? It could be a 3 to 6 months period. Anything we do that's not the full survey in that first period, of course, could impact DR1. And so we'll always have to keep that in mind and weigh what we do versus what the impact might be on data release 1. And of course, we'll hear a lot about the initial survey cadence and what the survey cadence optimization committee is doing. Anything we do differently than normal operations in the entirety of year 1 would have to be factored in at some point with that activity to understand if there were impacts on the cadence and what we hope to accomplish over the 10 years. So what would be the best use of this time period? These are the kind of questions that we're seeking input from the community on as we go forward. We certainly think any way we can align what we do in these first months, if we have to do something different, any way we can align it with as closely as possible with regular survey operations and data taking is good, because that just naturally supports DR1 and the rest of the survey. Time domain science, we want to make sure that we can enable that early on. And we will, as I said, Leanne will discuss a template, an incremental template generation scheme that we're going to implement. But there's still lots of questions about exactly how you do that, how you trade off generating templates across the sky versus maybe less sky and more filters, that kind of thing. It could be we would want to provide some static, small, contained data sets for the community to work on. So we might do some dedicated development of small areas of the sky to certain depth and certain filters for various science reasons that could be quickly put out and produced for the community. What are the specific things that might be needed for galaxies and cosmology in this period, if any, that we haven't otherwise provided for? What about a possibility of having some peer-reviewed competition for some small fraction of time in the first survey phase? That could be where people get to competitively put in their ideas. Of course, any of the data that came out of that would be available to everybody. And we could talk about how many such programs there might be. We're certainly talking about, in any case, a small amount of time. And so how do we develop the process? So that's why we want to make sure we get your input as we go forward, and we'll be talking to you over the next year or so to solidify these plans. And of course, we talked about some aspects of this at the session yesterday. So now we're going to switch over to Leanne to talk about alerts, but maybe, Leanne, we should think about questions if Chuck has gotten any.
Point.
Or if someone wants to raise one live.
So, Bob, one question. How often do the templates get refreshed?
Why don't I let Leanne cover that, because she might cover that as she goes forward with these slides.
Cover that on this slide. This slide actually has the answer to that question. So maybe,
Okay.
Chuck, if there are no other questions that you want to line up before.
No, I think the other questions, there haven't been that many yet, and they've been answered online, so we can
Okay.
go now.
So a quick introduction to alert production, and alert production, a new one. As Bob has just mentioned, alert production was not originally going to be part of the year one baseline. Alerts are a product of difference image analysis, and difference image analysis requires co-added transient-free templates. These are deep templates of the sky without transients that you subtract from your science image, the new science image that's taken, to see what has changed. So you can see in your image what has changed on the sky. In order to do that, we need to build up a library of templates, and we won't be able to do that for the whole sky and for every filter prior to the start of operations. We need to do that during the first year of operations. So these templates are built during the data release production processing, and they're made available through LSST data releases. And to answer the cadence question, the LSST data release schedule is currently an annual one, so it means that we will have one data release roughly per year, with the exception of the first year, which the first data release will be 1 year after the start of operations, but it will be based on 6 months of data. Going forwards, in subsequent years, the data releases will be based on all the data accumulated over time and released every year. So that's the baseline plan, and if we stick to that baseline plan, we won't have templates in year one with which to make alerts, which means that alert production cannot run at full scale or full fidelity in year one. And this is obviously problematic for early science, because we don't have any alerts, then LSST will be running for a year and there'll be no data products for people to work with. So, sorry, Bob, you have to go forwards.
Sorry.
I'm not sharing anymore.
I advanced it.
Thanks. So in order to understand how we could improve the situation for alert production in year one, the DM science team carried out a study of several options for alert production in year one. This study was led by Melissa Graham and conducted by the whole DM science team. And there's a reference to a tech note here that you are welcome to have a look at, which outlines our options for alert production in the first year of operations. So following this study, we got together, the DM science team got together with the PST and the operations project to propose a strategy for improving alert production in year one. And there are two components to this. One is that we take the commissioning data templates and we build we take the commissioning data and we build templates from that data where possible, from all the commissioning that is gathered prior to the start of operations. And we use those templates to generate alerts in year one. That, of course, is not going to give us templates for the whole sky, nor in every filter. Even if commissioning is the best it could possibly be, and even if Chuck were to get back all his descoped time, we still wouldn't have templates to make alerts for the full sky in all filters. So in order to improve the situation, we proposed this program of year one template building, whereby we build templates progressively from the data obtained during year one. So for example, on a monthly timescale, that's not a commitment, that's just an example. So on a cadence more frequent than a data release. And as we get enough images, we build a template and then we use those to generate alerts during year one, either instead of or in addition to the commissioning data templates. And so over the course of year one, we will increase our rate of alert production. And so this was the proposal that we came up with, which has been broadly accepted. Oh, sorry, Bob, you have to go forwards. So then following this, we did a sort of a study, a technical study in data management and had a look at some of our requirements. There was a change request put in to construct image differencing templates outside of the data release processing, outside of the data release production processing. Prior to this, the template images, as you can see in the first part of this requirement, were constructed as part of a data release payload production payload, sorry. We modified this and updated it so that this payload can be executed outside of data release production, and so that it can be executed when we have sufficient data available to create coads incrementally, provided that they satisfy a certain quality criteria. So this represents a change in the DM baseline. This was accepted. And so the DM system will be built to allow templates to be built at any time, provided that we have sufficient input data of sufficient quality. So a couple of points on this. To enable artifact rejection, the templates will be built with at least 3 images in year one and 5 in subsequent years. This is actually one of our high-level requirements. So in the first year, we will have noisier image subtractions. In the second year, given the templates we built from 5 images, they will be of better quality. Once a template is produced for a sky position and a given filter, it will not be replaced until the next data release. So this won't be a case of continually improving the templates throughout year one as more and more data becomes available. Once we have 3 images of sufficient quality and we make a template for a given pointing and filter, that's the template that will be used for the rest of year one until the next data release comes out. And just a final point is that these templates will not necessarily be built from the first N images that are collected. These would be the images have to satisfy certain quality criteria. So what are the implications here then for the year one cadence? What we have to do now, and I think Bob's already alluded to this, is decide how to build up these templates, how to build up this incremental template library. The science collaborations have started to publish research notes, and this was mentioned this morning in the science collaboration talk, that TVS and the Solar System Science Collaboration have published research notes highlighting early science opportunities based on detections in difference images and the sort of requirements that's going to place on templates. So do we maximize area versus noise in difference images? So different cadences and filters will favor different types of science. And we're probably going to need to run some simulations and present the possibilities to our stakeholders in order to make a choice as to how we proceed in building up these templates. And just to note that oh, it's okay. I think Bob had already made that point. So this here just shows you, this gives you a link to some of the research notes that I just mentioned that have been put out by the science collaborations already. The first one from the Solar System Science Collaboration, who outlined some opportunities for high impact solar system science during year 1, and 2 from the Transients and Variable Star Science Collaboration, which also outlined some strategies that will maximize their science in year 1. These research notes have been very useful to us and given us some insight and some guidance on the sort of things that the science collaborations would be looking to do with early science. There's also been some active discussion on the community forum, and I would encourage everyone to go to the community forum, follow up on this, add their thoughts on it. There's a thread here on science-driven prioritization of sky templates during commissioning. Yeah, this is active. Please feel free to go and contribute to it. Bob, if you could move forwards. So if I just pull out some of the considerations from these research notes and from the discussion that's been happening, high impact solar system science, for example, prefers template generation that maximizes sky coverage. Whereas time critical TVS science is enhanced by templates in multiple filters, preferably the R and the G band. To address a range of variability timescales, TVS would also like that templates be generated from images collected at a range of time separation. So you can see that these are some of the different considerations and the different points that have been raised in these research notes and discussions that will be, I guess, that we have to think about when we decide how to run this template building program. Something that's common that I hear quite a lot is that noisier image subtraction compared to data release 1 is preferred to no difference image analysis at all in year 1. So people are happy to work with noisier data as long as they get some alerts and get some difference images.
Okay, so coordination of early science. We've begun working in various fronts to coordinate ideas. And I think it's fair to say that there are probably parallel discussions and parallel streams of thought on early science. Certainly the alert discussion that Leanne was just covering, some of the ideas that I mentioned, and then this particular one with the Survey Cadence Optimization Committee. And I think the time is now where we try and pull all these together into a coherent set of plans or options as we go forward. And certainly we do that with your input. We're all in this together. So the SCOC and the SAC have been working on this topic. And the SCOC was actually charged to deliver some recommendations, and we'll look forward to those coming out as well as that process goes forward over the next year or so. So we're reaching out, starting now. If we it hasn't been obvious that we started before. We'll review the community feedback on alert generation, understand what's possible and what the implications are for those various scenarios, and present it to the SCOC for their recommendation as well as we work with them and finish up the actual cadence, which starts, of course, in year 1. The full Rubin observable operations proposal will be submitted as part of the NOIR Lab overall proposal for funding from the NSF. That will go in December of 2021. Of course, the DOE funding process and review of all of our operations plans will be included. The DOE is done more on an annual cadence as we go forward once they've decided the project is in the long-term plan, which they certainly have for Rubin. Before COVID started, we did aim to have an initial plan for this kind of wrapped up by the end of this calendar year. I think that's unrealistic and unwise because of all the reasons I started out discussing, which are that we just don't know enough yet about where we're going to be. But we should soon. The project is working very hard on getting started again, making the plans for when it's safe to start construction in Chile again. We all hope that's soon. They've started doing some work very carefully and with significant COVID precautions on the camera again in California, as you heard Steve and Victor talk about on Monday. So hopefully within this last part of the calendar year, we'll know a lot more about what we're looking at as far as starting the survey, the plan for starting the survey on at what time scale. Probably something like 6 months to a year later than what we have been discussing up till now. So I think we'll probably postpone making a final plan for early science until later in FY21. And we will just continue to work with you on that as we go forward. So we want to go through some advanced questions or take a from the floor or from Slack, Leanne?
So I think that given that a couple of people made the effort to submit some advanced questions, we should probably address those first.
Sure.
Questions from the floor. So we did solicit questions in advance of this session so that we could prepare answers for you. We got one from Nick Walton, who's in the STARS Milky Way and Local Volume Science Collaboration. He asks, what are the plans for coordinating the publication of science results from the early commissioning and science verification data? Likely better if all the science from the early phase comes out as one special issue of a major journal. It takes a bit of organizing, and what are the timelines? So I know what Nick's talking about because we did this in Gaia. I worked with Nick on Gaia Data Release 1 and Data Release 2, and for both of those data releases, we had special editions in ANA, which you can see here. So from the LSST side, at this time, we are planning a series of construction papers that will close out the construction project and describe the as-built system and its performance on the commissioning data. I think this is a great idea to publish these papers in a special edition of something like ANA or AppJ or a major journal like that. And I will certainly be following up with that in the project. We haven't made a decision on that, but I really like the idea. And it certainly worked very well for Gaia, and it's worked very well for a lot of other surveys. I will just stress though that once the data are public through Data Preview 1 and 2 and through subsequent data releases, scientists are free to publish as they wish with the data. They're free to take that, data rights holders of course are free to take that data and publish their science.
Okay, thank you.
I don't know if Nick's on, but I hope that answer addresses his question.
Yeah, could I just say a quick word?
Sure, go ahead, Nick.
Raise hand, sorry. Yeah, no, that sort of answers it. I would strongly recommend you do try to get a bit of coordination from the science collabs to, if they can, get the papers out at a similar time, because if you go for this sort of drip drab, everyone rushing for the quickest result, you'll find that after a little while that probably the impact will go down. So if you can do that and sort of bring together some sort of community science survey type idea, I think you'll get a bigger bang in terms of visibility, and that might be quite important. And it also might make sure that a lot of things happen at once. So I mean, that, you know, it's a big initiative, but perhaps that would be an idea to get the science collaborations at least together, so that they can do that, even at the risk that somebody else pops out a paper. You know, who cares at that level?
Yep, that's really good input, Nick. Thank you. I think that's probably something for Fed and I to take away and think about, or for the operations team to work together with Fed and the science collaborations to think about how we could get the most impact with our first set of papers and releases.
Yeah, for the rest, I'll leave it at that. Thanks for taking the question.
Thanks, Nick. Okay, so the second question came from Preeti Nair from the Galaxy Science Collaboration. I hope I've pronounced your name correctly. Who asks, what products will be included in the early science data? How will the early science data be distributed? Who will have access to it? What are the conditions for access? How is this data different from the scheduled data releases? And what results from the early science data will be disseminated within the science collaborations and beyond? So there's a whole bunch of questions here. I'll start just by saying that the data products will include images, alerts, and catalogs, However, the exact nature of the science data products, so that is the format of the columns in the catalogs, the exact contents of these catalogs, we won't know that until we're much closer to the date of releasing these data previews. As Bob outlined earlier, a lot of what we're going to be able to do and release in early science is going to be dependent upon what comes through commissioning, and that also, and then also what science pipelines we run and what science we can get out of the processing. So the data products definition document has a sort of nominal science data schema in there. And as we get closer to the date of release, we will update that with an exact definition of what's going to be released in the data products.
And so I would add to that excellent answer, Leanne, that whatever we do for the data release or data previews in pre-operations to the community, to the data rights community, will be done equally for all data rights holders. That doesn't necessarily mean, especially in the beginning, that we'll simultaneously provide access to everybody, but we'll have to figure out a way, if we're limited on the number of users, say in DP0 or DP1, we'll figure out a way to give everyone equal access over time to the data.
Thanks, Bob. Okay, so to continue on our response to this question, we just want to point out that early science data is going to differ from the scheduled data releases in several ways. The exact data products that we release may only be a subset of what is offered in a full data release. That's one way in which they might differ. Alert production will not run at full scale and full fidelity until after DR1, so there will be differences in the alerts and the prompt data products. And we won't have full sky coverage, and we won't have coverage in all filters either. So basically the commissioning data used for early science is not going to look anything like that of the main survey. Primarily there will be differences in temporal sampling. For most fields during commissioning, the temporal sampling will be much denser. So these are things to bear in mind when you start to work with the early science data sets. The data releases in future years will look different.
Yeah, and if I could channel Chuck Claver, he would say that those differences actually are great science opportunities to get different kinds of data sets that we won't see in the regular, which will also be great opportunities.
Yep.
Thank you, Bob.
Okay, so I think now we can open the floor up to additional questions and discussion. That maybe we'll go to Chuck and see what's been queued up on the Slack channel.
Yeah, there's been a lot of traffic, so let me see if I can distill this down into a series of questions. A lot of them, there's been a lot of questions about templates. I think most of them are being answered in the threads. So,
yeah, I see that the team's doing an excellent job of fielding the questions and giving some great answers. Thanks, team.
yeah. So there was one question here from, I believe it's, I'm sorry if I bungled the pronunciation, but Wesley Fraser. And the question is, when should we expect to submit formal feedback from the science collaborations about early science plans?
I'll take a shot at that. I think we will probably we will certainly open up some channel for feedback about early science plans. And as we were saying earlier in the session today, I would expect that to come out in the next year. And we'll work with the SAC and the SCOC and other community-based groups, advisory committees in the Rubin enterprise to come up with the right plan for that. But yes, we will get specific input from the science collaborations, who after all are a big part of the science community and the organized part who we know have good input for us. So yes.
So even though there's been a theme, one theme that's come up in several questions is about the templates and whether in the first year data from other facilities, other wide field facilities like DECCAM or SDSS could be used to formulate the first generation of templates. I think those have been answered, but maybe it's worth commenting on for the larger audience.
I'll let Leanne or one of the team take a crack at that one.
I was actually going to ask Robert Lupton, since he's given the answer online, if you'd like to comment on that.
Which particular aspect of template generation do you want an answer on? I've been typing a lot.
Yes. So Robert, the question, I was trying to synthesize multiple questions into a summary one. And the question is, can data from precursor surveys or precursor efforts be used to produce the first generation of templates?
Yeah. Okay, so that's difficult. It's partly depending on what we believe about LSST seeing. If we believe it's going to produce 1.5 arc-second images, then sure, you can use almost anything. If we believe it's going to produce the as spec, then most of the precursor data isn't as good as LSST, and it's really hard to use that. Plus, there are problems with filters. I don't think that's much of a problem at GRI. The UZY filters from DECAM, which are the obvious southern thing, are really quite different and quite a lot shallower. Also, we can use single epoch, though Leanne said 3 epoch, but we should haggle over exactly the scientific optimum to get things out. And depending on what you're trying to do, if you're trying to look for bright asteroids, a single epoch's good enough. If you're trying to look faint, it clearly isn't. So I just don't think we know what the full range of trade-offs are between possibly using best quality DECAM in some bands through 1 or 2 epochs in ours just to get early stuff out before we move on to the stable templates that Leanne needs so we can actually define light curves. So I think we can make most of you happy, but not all of you. And if you're one of the people who's not happy, it's not my fault.
I would add to Robert's answer that if you think about what it takes to do that kind of effort to use a precursor data sets to do that job, I think the capability of LSST is so great to generate some of that early data itself that the trade-off would be in favor of the incremental template generation that we're looking at.
That would be my guess too, Bob. Potentially starting with only 1 or perhaps 1 exposure is enough to get some science out. If we get clouded out for 2 months, then we'll switch our strategy. That is my guess.
And we certainly agree there are very many good DECAM and HSC and other images out there. Chuck.
Okay, just got a new one in here. So other surveys, this is from Federica, other surveys use more than 3 images for the templates. What consideration led us to believe that the number of 3 visits is optimal for generating a template, or is that optimal or minimum?
Yeah, so let me take that. It's not optimal. It's more of a minimum. There is a requirement in our requirements documents on the amount of noise that can be contributed to a difference image by a template. And in year 1, this requirement is looser than it is for the full survey. And if you do the calculation, it turns out that you can satisfy that with, I think, 2.5 images. So we go for 3 images. So basically it's minimal in order to be able to get difference images and do alert production early. In subsequent years, this number goes to 5.
Okay, a related question, I think this also has been answered in the thread, but might be worthwhile for everyone to hear it. How often do we plan to refresh the templates throughout the survey?
With every data release production release, with every data release, which is annually. So every year we will reprocess the full data set and produce new templates with every data release.
And we're aware that this is tricky, especially by the time you worry about moving things, tying all the photometry to one system. It's complicated. Yeah.
All right, I'm scrolling up through the Okay, so there's a new question. Defined system.
Mario's just posted a good question. which I can
Yeah,
take
so
a
the
stab at.
mentioned LCR specifies the DM system will support incremental template building capability, but I'm confused if the decision to do incremental templates in year 1 has been made as well. If not, is there a timeline?
Yeah, so there are sort of two parts to this. One was a technical study to assess what we needed to change in the DM system to make this happen. That was done. We submitted the LCR, the change request, and this has gone through. So the DM system is required to provide a system that will allow us to build templates outside of the data release production standard processing. The next one is, of course, the decision as to whether we're going to do this. I don't think, Bob, correct me, I'm not sure if there's been any sort of official process at the project level, but we are certainly planning to do this as far as I know.
I think this is the leading idea to enable some early science in year 1.
Yeah. Now, I think if you go back and look at the tech note that the DM science team wrote, led by Melissa, this was the best option that we could come up with in order to maximize early science. And so this is what the DM science team are strongly recommending to the project that we do.
Yeah, and if Mario's question, I didn't really hear the end of it, was this an officially decided? The answer is no. We will have an official decision as we go forward, but well in advance of operations.
Mm-hmm.
We can take questions from the floor too. I think people can unmute themselves, right?
Yep.
Sure.
I think, unless I've missed something, I've captured, I think, most of the questions that are on the Slack channel. So people from the floor should chime in if I've overlooked something.
Go for it, Michael.
Chuck, this is a comment, not a question, but at least I'm not trying to book a flight while talking and listening to the talk. I think there's actually formally a risk for months 12 through 18 if year 2 doesn't come out till the end of year 2. You won't have templates for that part of the sky. I don't think anyone's actually doing that or actually proposing that, but if we're going to sit down and formally read baselines, that's also a risk. Yeah,
I can take this. Yes, thank you, Michael. In fact, I did touch on that point when I gave this presentation to the PST, but I didn't go into that detail in this talk. I probably should have. Even with the incremental template generation, we won't, given that data release 1 is based on the first 6 months of data, we won't have covered the whole sky going into year 2. So my expectation is that we will almost certainly have to continue this incremental template generation into part of year 2 in order to fill out that part of the sky. So going into year 2, we will obviously use the data release production templates where they're available, and if not, we don't have those. I think that my recommendation would be that we continue to run the incremental template generation.
So I've got another template, or not template, but question, sorry. Will we offer the user the ability to generate their own templates and redo the subtraction with their favorite template selection? Who wants to take that one?
I was replying to Mario online.
I can take that one. Yeah, sure. Why not? You have access to the images. You have access to your code or our code. You can run it in the LSP if you get enough cycles.
RSP.
RSP, sorry, that the LCR went through. For those of you who don't like acronyms, the Rubin Science Platform, because the L standing with something I don't know what it stands for, change request went through.
LSST change request.
Ooh, ooh.
Yes, and in fact, just to add to what Robert said more generally, using the Rubin Science Platform, you should be able to run any of our code and to regenerate these intermediate data products or intermediate data products.
Or your own code if you want to be more ambitious.
Yes, or your own code.
Yeah, so Robert, there's also a related question that I think you guys have answered in the thread, but I'll pose it anyway about how will the templates be generated from just only the best seeing images available, or will they use the entire data set to produce templates? I think this is related to another question that I asked you.
Do you really want us to go into all the horrors of template generation and the trade-off between correlated noise and high frequency power? The fact that you only need to actually deconvolve to the likelihood image, which is the PSF convolved science image, except you have to worry about correlations. I'm happy to discuss it, but I'm not sure this is the right place. It's complicated. Ideally, you would take a very high signal to noise set of extremely high signal to noise images. And for point sources, that's what's optimal. If you're worried about extended sources, because you're worried about light echoes and comets and things as well, then you can use a different template that preserves the high frequency power but has higher signal to noise and the low frequency power. And all of these things have discontinuity problems as you get to the edges of chips and the edge of the camera. So that makes it more complicated again. So I can't give you a simple answer, except that it's not simple. And I think we're going to do a decent job making people happy, but if you've only got one epoch or a few epochs, it's harder.
Okay, so I kind of got myself out of sequence here a little bit. Mario had a follow-up comment about the timeline for making a decision on the incremental template generate, or what the plan is for the template generations in the first years, and making it difficult for scientists to apply for grants during the first year of science. So do we have a timeline? I think it's the question that Mario is asking.
Yeah, I'm just reading the follow-up to this. So I think the answer to the question is we don't have a timeline, but we need to get one. Well, both Brant and Mario are pointing out key dates towards the end of this year for submitting grant applications. So I think that's an action on Bob and myself and anyone else in the project to take this offline and come back with at least a process for getting a decision on this, if not a decision itself.
I'm just wondering if a big part of that is the rebase line of construction, so we know how much template generation, for example, was created during commissioning versus first year operation.
So if I can respond to that, even if we have perfect commissioning, even if commissioning is absolutely spectacular, it produces wonderful science quality images, we're still not going to have covered the whole sky in every filter. There will still be an advantage to be gained from running this incremental template generation in year one to improving our science.
Could you write down that description you just had of commissioning, please?
And the other thing is, yeah, look, we get it. It's an important point, and we will work urgently in the near term, where that means sometime in the next 6 months, to get a better answer for this. But again, we still don't even know when the start of operations is likely to be, within at least that level of uncertainty.
Let's see, we have one last question that came in. We're getting close to the top of the hour. So how old can images be and still be useful for building a template? E.g., can the end of year 4 data release be used, use images from years 2 and 3 to build a template?
That depends on what you believe about the faint moving sky primarily. For the extralactic case, it's fine. If you think that we're going to get a significant contribution from M stars, then it's less obvious. So it's probably a statement about galactic latitude.
Yeah, more specifically, Robert, this is from Peter Yoakum. And the question has to do with the fact that we won't have that many U-band images per year, and how we build, more or less, how we build templates in the U-band.
Well, it's a trade-off. Do you do worse because you don't have a good U-band template than that you've got things moving around the sky giving you dipoles everywhere? And I don't know the answer. I think it depends on latitude and signal to noise and seeing and distribution of our mass.
Right.
So again, there's no simple answer. Please, there's no
All right.
simple correct answer.
Have a look at Peter's comment in the Slack channel and see if you wanted to respond to that. But Bob, I think we have the Slack channel discussion covered at this point.
Okay. We have a few minutes left, so we can pause for just a second and see if there's any live questions that someone would like to ask, and then I will hand it back over to Leanne to close this out.
And I guess I'll add a reminder that if you have ongoing questions or want ongoing discussion, continue with the Slack channel. Some of us will be looking at it from time to time.
Okay, so looks like we have no more questions. Thank you very much, everyone, for joining our session. We had was it something like 200 people? We had over 200 people joining us today, so it's very exciting to see everyone so interested in early science. We're very excited to hear your feedback, and thank you for all the excellent questions. This is really important input to us in planning the early science program. So, yeah, thank you very much.
Thanks, everybody.
For those of you that are still on, there's still more questions coming in, so have a look at the Slack channel.
I will continue to follow up on the Slack channel. Thank you. And thanks to the DM team for the super responses on the Slack channel. Really, really prompt, really nice responses. Excellent to see.